All right, let's find the area of it. And you guys use every geometry, not all the geometry knowledge you may have, I hope you have, to find the area. First thing, I need to introduce you guys or reintroduce you guys to a new segment. And that's the segment that's labeled as 7 centimeters. You are not used, and you probably don't even know they existed in polygons. You think they only exist in circles. Yeah, that's a radius up there. Okay, they do exist in polygons, drawn from the center of a polygon to a vertice. That is called a radius. And yes, they are all congruent in the same polygon, just like they were for circles. So I'm giving you a radius of 7, and I want to find the area of this square. Right over there in the back. Now, right off the bat, we have not done squares, and you told us no new formulas. I'm not going to give you a new formula. I'm not going to even add in square to it. Here's why. When we did the quadrilateral unit, and I introduced the whole family tree, anybody remember square was at the bottom of one family? Anybody remember the 3 figures that were on top of it? So a square is also this. A square is also this. A square is also that. Matt, what was one figure above it? A rhombus, yeah. A rhombus was above it. What else was above it? Well, a rectangle, and then at the very top of it was a parallelogram. See these 3 I just wrote up here? Those are 3 you have formulas for. So if you want to find the area of a square, you can use one of these 3 formulas. All right? 1/2 d1 times d2. Length times width, base times height. They're all squares. Square is a rhombus, is a rectangle, and is a parallelogram. So I don't need to give you a fancy new formula for a square. You can use one of these. So that's what I want to do in your group right now is you pick which one you want to use and find it. So if you choose rhombus, you're going to have to find the diagonal lengths, knowing what you know about a square. If you want to do rectangle and you choose to do length times width, what do you know about the sides of a square again? All the same. So you find one, you know the other one. I'm not going to tell you how to do this, all right? Because it would drive me nuts that I'm making you guys do it one way when there's like 4 or 5 ways to find the area of this square. All right, so you talk it over in your group right now, and we'll come back and say, all right, how many found it this way? How many found it this way? Tell me how you found it. And keep in mind it's a square and it has a ton of properties. All right, so find the area of this square any way you want. And you guys, you're allowed to draw in more things if you need it, right? You know, 1 radii is 7, so that means they're all 7. All right, let's go. Anybody using the rhombus formula? Rhombus formula, 1/2 d1, d2. Yep. Hey, if you use the rhombus formula, there's a diagonal. That's got to be 7. So that's 14. And I know for my square properties, diagonals are congruent to the other diagonals, 14. So 1/2 times 14 times 14. All right. Anybody draw in, let's say now this way. Anybody draw in the radius going that way and say that was 7 to find the side? Yes. Quickly. You use Pythagorean theorem, but what gives me the right to put a right angle in there? It's a square. Diagonals are? Well, they are congruent, but I put the right angle because they are perpendicular. So that gives me, and now you can do 7 squared plus 7 squared equals c squared. Find the side and multiply it by itself. Did anybody do it this way? Let me draw in that other diagonal. and know these sides are the same, and now do Pythagorean theorem on that right triangle. Anybody do it that way? No? Okay, am I missing a way then? Anybody find the side length the other way? Another way, or are we good? Okay, fine. No matter how you did it, what did we come up with the area for this square? No matter how you did it. Plane with fire, I don't want to go over there. Nope. Nope, I'm getting there. Haley. Let's go. 98 square centimeters. Yep. All good. Questions? All right, let's do this again now, but with a triangle. All right, I am going to just help you out with this one. I'm just not going to let you go in your groups here. What's the 4 I gave you? That's a radius of the triangle, right? That's a radius. All right, we do have a formula for this, though, and it is 1/2 base times height. So that's the formula I'm going to use. Quick reminder, if you didn't see it in the directions, this bad boy is equilateral because that'll come into play knowing it's equilateral. Whew, all right. Remember, any base doesn't necessarily equal bottom. It could be any of those 3 sides. It's whatever we draw the height to. So now we got to make a decision. Where's the height coming from and going to? I know probably the best way is from the top vertice all the way down. And the heights, altitudes are perpendicular. So there's the height I need to find. Before I move on, I know the length, not of the whole height, but a part of it. Anybody know part of the length of that height? I don't know the whole length, but I know part of it. See, 4. The radius is 4. Is in this part right here. That's 4 as well. All radii are congruent, so that's 4. Ooh, nice. So all I need to do is find that piece right there, and I'm good for the height. And then somehow we'll get, and I'm just showing you, that's going to be our base, however long that is. All right, how are we going to get there now? All right, let me help you. How are we going to get there? Do you see this right triangle that we have there with the radius as the hypotenuse? Everyone see that? I want another angle inside that right triangle. I want another angle in there. And watch where we go. Matt, what's up?
Almost is 30.
Go ahead, keep explaining.
Okay.
This is what type of triangle?
30, 60, 90.
Well, it will be. I'm saying equilateral.
Oh, yeah.
Right? Equilateral. First thing that comes to mind is, all 3 sides equal. Yeah. Good. But also all 3 what are equal? Angles. So what's the measure of one of those angles in the equilateral triangle up there? 60. 180 divided by 3. So take a look. This whole angle right there is 60 degrees. And I could get into congruent triangles and CP/CTC again, but guess what the radius is doing to that angle? Bisecting it. So that 60 becomes a 30 right there. And yes, now what's it become, Matt? My right triangle is a 30, 60, 90. Good job. All right. So now that was a 30, 60, 90. And I'm hoping now I'm going to let you guys go back to your group. Find the height now. Find the height. What is the height of my triangle now? Using your 30, 60, 90 rules, do we need to review them? Hypotenuse equals what? And a 30, 60, 90? 2 times shorter leg. And what's the longer leg equal to? Shorter leg times radical 3. Yep. And what's the radius of 4 acting as? That's my hypotenuse. And I'm looking for the shorter leg so I can add it to 4. If my hypotenuse is 4, what is the shorter leg then? If the hypotenuse is 4, what is my shorter leg? Amy?
That's not me.
No? Who's okay, then I just totally botched that. I thought I was pretty confident then. What are you, 8, Ian? Olivia?
Who's your favorite student in this class?
Not Josh, but that's how I know it is, who it is. So good try, though. Josh, what's the side across from the 30? 2. Everyone agrees? Half of 4. So here you go. Now going back to the area formula. 1/2 base, height of 6. All right, now get me to the base. If 2's the shorter leg, what's my longer leg? 2's the shorter leg, what's my longer leg? Not here, I knew that one. Gabby? 2 radical 3. Ooh, be careful though. Hey, ready? I was ready to do that right there. 2 radical 3. No, that's not the base. That's just this side right here. 2 radical 3. But guess what the height is doing to that base? These 2 big triangles are congruent up here by side, 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 or any method really. It's bisecting it. So one side's 2 radical 3, other side's 2 radical 3. So what's the whole base I can plug into my formula now? Whole base. Olivia? Yes. 2, what, sorry? I was just so jacked up I got that. 4 radical 3, yep. And we leave our answer in simplest radical form. So what's that going to be? Half of 24 is 12 radical 3. Let me check. No units on my diagram, so I won't expect any on your area. So a little tougher to get to the area. You got to use your geometry here. All right, now here's the big one here. Can I move this? I really don't want to go back. Yes, I can. Nice. All right, I won't deny it. Don't worry. I know I cheated there. There you go. Okay. Hexagon now. Hexagon. All right, I'll get to the top of the page in a second. Hexagon. Anybody know area formula for hexagon? No, I didn't think so. And I'm not going to give it to you because you have too many formulas to deal with anyway. But if you want, hey, let me just drop some knowledge here. There's the area formula for a hexagon. If you want to memorize it. 3 radical 3 over 2 times the side squared. Okay, there it is. I'm not having you guys responsible for that though. Don't draw anything. If I draw in all 6 radii, everyone see I formed 6 triangles inside the hexagon? And they're all congruent. So how am I going to have you find the area of not only a hexagon, but heck, any problem, any polygon going forward? We're going to take one of the triangles formed and find the area, which is what? 1/2 base times height. So we're going to take one triangle, find the area, and then at the end, we'll just multiply it by how many triangles there are. In this case, 6. Right? We don't need another stinking formula. Plus, tomorrow, we're going to do octagon and pentagon. And you don't need more. All right? You've had enough. I think there's 7 formulas you're responsible for going into Tuesday's test. You don't need more. So any polygon going forward now, we're just going to find the area of one triangle and then multiply it by how many triangles are in the figure. Good? All right, let's talk about this triangle right here, ABC. Let's try to find the area of it. I already gave you 3. What's the 3 here? What's the 3 represent of that triangle we're trying to find? Zoe? That's the base. You're welcome. 1/2, 3 times, now we got to find the height. All right, and the height is BD. All right, so how am I going to find BD now? I want to get more information for you for that one of the right triangles. Let's start with BDC here. What do you think the height's doing to the base of 3? That's HL right there. So CPCTC says what about AD and DC? Congruent, it's bisecting it. So I'm not going to use 3, I want to use 1.5. Get me more information about right triangle BDC. Get me more information. Here's how we're going to do it. Can you help me find this central angle right there, angle ABC? Find angle ABC. Ooh, how can I do that, you ask? All right, well, let me draw these radii back in. There's 6 of them, 6 central angles, and they're all congruent, and they add up to what? If I add up all these central angles here, they add up to 360, yep. They They add up to 360. So divided by how many they have. What's one central angle measure then? One central angle measure. Gianna? 60, good. Now watch what I know you get, you don't get excited. Who am I kidding? But you see 60 and you're thinking 30, 60, 90. Make sure you know where this 60 is going to go. That's angle ABC. The height is bisecting it. So I'm not going to put a 60 here. I'm going to put the 30 here. That's 30 because ABC was 60 and it's getting bisected. Now the other 60 can go right here. There's the 30, 60, 90 triangle. All right? So find the central angle by taking 360 divided by how many triangles there are. All right, use your rules. What's my height now? The side across from 30 is 1.5. So what's my height across from the 60? Across from the 60, what's my height here? Oh, Jesus. Is that you? Yeah.
3 radical 3 divided by 2.
1.5 radical 3. Yeah.
Oh, well, yeah.
Yep, that's fine. It's the same thing, what you said. It'll work. And don't forget to multiply that's only one triangle. Everyone agrees that's one triangle in here out of the 6. Multiply your answer by 6. The directions say I need 2 answers here. One is going to be simplest radical form. So you can get that from your calculator. Remember, you can highlight the decimal answer and it'll give you in simplest radical form, I believe. All right, so when you have it in simplest radical form, let me know. Charlie?
Radical 3 over 2.
Yep. Okay, well, just let me talk here for a second. That's correct. 27 radical 3 over 2, right? If anybody had 27 divided by 2, which is 13 and a half radical 3, that's the same thing. Okay, same thing. And what is that, meters squared? All right, then I also asked for that answer rounded to the nearest 10th. Rounded to the nearest 10th. Did we just have this with you? It is. My memory is off. Like, it usually is pretty good. But what do you have?
23.4.
23.4. All right. We're all good? All right. I guess I got to figure. Sorry, I got one more to do, right? This one. Just to get this to be official. I'm not going back all these slides either. Couple curtains today. All right, because we're going to do a day 2 of this tomorrow with different polygons. So if you want to find the area of any regular polygon, what was our move? Find the area of a what first? Find the area of a triangle. So 1/2 base times height. And then we multiply that by what? Number of sides, number of triangles formed. They're both the same. I'll go number of sides. That's probably easier when you go back and review. Times the number of sides. And just make sure we know here, 1/2 BH, that's the area of one triangle formed. All right? All good? Questions, comments, any concerns? You guys can get moving on the assignment now. I've had plenty of time over